Good afternoon. So the next speaker is Dil Tirimana. I can introduce him as director of FDN Group, FDN Engineering, and FDN Construction. He's a constructor and design engineer with the known design bureau, where they developed the calculation for UHPC. And they are now busy with the building of a new sluice gates in UHPC. So he will explain more about these new projects in his presentation. Can you share your presentation, Dil?
I'm trying.
I will first stop sharing.
Yes.
I hope you can share.
No, I see that I cannot share it. Can you see it? I'll try again. Is it on, Tom?
Yes, now we see it. Can you make full screen mode?
Yes.
And then you can start presenting.
Yeah, thank you very much. I'm Dil, and Dil Tirimana from FDN Group in Amsterdam. And we have done a few projects in UHPC, and today in my presentation I will go into the projects we've done in 2021 and 2022. So some projects are in progress, they are not finished yet, but I'll give you some small indication of what we are doing.
Sorry, Dil, can you make the full scale, full page?
I've done that already. Can you see it?
It's not the full scale, the full page. Please try again. Yes.
Okay.
It's multiple screens.
Is it okay now?
Change.
Okay. It only changes on my computer. Otherwise, you can share it, and then I can also speak. That's also possible. Shall I stop sharing?
Continue, Dil.
Is it full screen or is it just one?
It is okay, like that you can continue.
Okay, Tom. So the first project I will explain, which we finished last year, is a bridge, and it's a 50-meter length bridge with steel railings and a UHPC deck. So this bridge was won with a tender. The main contractor was Knips here in the Netherlands. They are in Almere. And FDN had a collaboration with Waco, that is Concrete Valley, with Ron van Boven, to produce the UHPC deck elements. So the deck elements were about 5 meter by 3 meter size, and we had 14 of these deck elements. Here we see the elements which we made in Bergen op Zoom at Waco. And Aalborg Extreme was used as the UHPC. So it was quite a complicated connection, which another group also designed for the tender. And So yeah, with very slender, what do you call it, connection plates, as you can see on this slide. So it was quite, and it had to be also produced in a few weeks' time. So it was a more logistical problem also than just design problems. Here you see the connection with the steel railings and the UHPC plates. So there were welded rebar onto the steel railing sticking out, and then we made an in situ connection of the plates to the steel railings. So this whole bridge was built in 1 weekend. Actually, Friday, Saturday. It's a long weekend. Friday, Saturday, Sunday. So it was only possible in this precasting method to do this with the large steel railings. So we also advised to do. Actually, we researched whether we could do also these railings in UHPC concrete with post tensioning, but yeah, that was too difficult. The steel railing was much lighter to handle and to be placed in 1 weekend. So that was the choice. Here you see the on-site work. It was actually the whole weekend, day and night, we were working on connecting also the plates, the UHPC plates, towards the railings. So it was mixed on site and then poured on the connections. And you can see here that these were really small mixers, about 400-liter mixers, which were hired for the on-site connections. And yeah, the mixers were just too small, so it was quite a lot of work to mix and pour this concrete. In retrospect, we think we would have done it much differently if we had another project like this. Here you see us, yeah, we didn't have this kind of mixer. This is a large mixer with about 2 to 3 cubes of concrete, which could be mixed on site. So this was only available after we finished the previous project. So there was not much chance, but this would have made the job much easier to fulfill. This is the photograph of the bridge, 50 meters length, and the railings were quite, it had a quite modern design compared to some railings I'll show you in a little while, because it was a slender steel design for the railing. And you see the plates here. And this installation of the plates was done actually within about 5 hours. All plates were laid between the 2 railings, and then it took us about 24 hours to make the connection between the plates and the railing. This is another UHPC bridge project where we tried, because we are also mainly structural engineers, so we tried to make it as slender as possible for a bridge, for a pedestrian bridge. So these railings have a thickness of 50 millimeters. The positive thing is that we tested the railing and it fulfills the 3.5 kilonewton load horizontally. But only problem is that the client still does not really believe that this is possible. And so we still have discussions about the 2 bridges we built with this railing. But it fulfills. So it's calculated according to Eurocode. But of course, when you're using UHPC, this was a UHPC C130/145. The Eurocode does not comply with this material. So we always resolve in testing. So then you do get a little bit of confusion or discussion with the client about what is allowed and what is not allowed. And in the end, you end up in doing a test to prove that railings fulfill for these loadings, for the Eurocode loadings. This is a design made also with a high performance concrete, but it's a design for a printed bridge. And this bridge is, we did the design work and also the research to make this bridge. It's not constructed yet, but this is a railing that has been printed. And also the main structure of the bridge, that will be the next slide, which looks like this, is a arch configuration. And it's actually made out of printed parts which are connected to each other with UHPC, and with a high strength concrete also the connections should be possible. But we wanted actually the bridge, and it's also not a pedestrian bridge, it's a heavy traffic bridge. So we designed the bridge for a 30-meter length. You can see the arch is about 24 meters long. And we incorporate foundation piles, steel piles, in the printed bridge structure. So if you see the next slide, here we are busy actually printing with a concrete printer. We are printing the layers. It's a C90 quality concrete, which has been used as printing. But that's not sufficient for a heavy traffic bridge. So after each print layer, we are by hand laying reinforcement in between. So this is a group of about 5 persons who are for one beam laying the reinforcement. So we do think that in the future, probably there will be some robot doing this work, laying the reinforcement. But for now, we have to do it by hand until such a robot is developed. This next slide is the finished half arch of the printed bridge design. So you can see the end result on the left, and on the right you can see that after a few layers of printed concrete, we have placed the reinforcement in the layer. Yeah, this is me standing next to a setup which we are testing on the heavy traffic loads. So in the middle, I'm not sure whether you can see it well, on top of me standing here is a UHPC connection between the two arch parts. So we printed the left part and then the right part, and then we connect it with the UHPC in the middle. And this beam was tested up to the Eurocode heavy traffic loads. Next slide. This slide is about a step which we optimized. That means we made for a staircase, for a school, we made steps with a thickness of 35 millimeters. And yeah, then again, because it was so thin for a building step, for a staircase, that we ended up in a lot of discussions also, whether this complies and whether not. So we had to test the step, and yeah, with calculations, you know, calculations are always conservative. So we were quite sure that this complies. But then during the test, you could see that it could have twice the load of the ultimate limit state. So in that case, also our client was quite satisfied that there was still, although the step is so thin, there is sufficient safety against collapse. The latest also, no, not latest, because we are doing this project researching for almost 3 years now, including the Corona period, is making sluice gates with a dimension of about 7.5 meters to 5 meters, for the province of Groningen. So we first did material testing, then we did also collision testing on thin plates, and after that we started the construction phase. And I can show you on the next slide what the sluice gates looks like. This is, we are calling it the first slender UHPC sluice gates. And the thickness of the plate of the sluice gate is 60 millimeters. 60 millimeters, and we use rib structures to stiffen the plate where necessary. And yeah, it should be able to withstand heavy ship loads. But of course, the reason we are making floodgates or these sluice gates in UHPC is for maintenance. And also, yeah, one problem was that it has to be a light structure, because previously there were wooden sluice gates there. So we have to comply with the load the existing concrete structure needs for all the joints of the sluice gate. So that's the reason we have chosen for UHPC. And the top part is just a thin plate with ribs, and the bottom part consists of two plates of 65 millimeters with EPS core. So that's the part that goes underwater and gives like an uplift for the floodgate to make it even lighter. This was a slide. I do not think it will work, but when the presentation gets shared, you could click on it, and you will see some testing we are doing on thin plates of 65 millimeters, where we have a like a kettlebell of 45 kilos, and we lift that kettlebell up with a crane, and we loosen it on the 60 millimeter plate to see what happens. So according to the tender regulations, we had to do a test with a kettlebell of 45 kilos and yeah, drop it from a height of 3.5 meters onto the thin plate. But in reality, nothing happened from 3.5 meters. We lifted it up to about 22 meters. And when you make your calculations, the load that is on the plate by this kettlebell is about 30 tons when you lift, make the height about 22 meters. So we dropped it on the plate, and yeah, nothing happened. The plate just survived this load. So then our client, the province of Groningen, were also quite satisfied that small ship collisions will not cause the door to collapse. These are some photos of the production of the sluice gate in Groningen itself at Heidsma. That is a large precast builder. So we use traditional reinforcement plus fibers for this gate. Here you see the reinforcement with the hinges of the sluice gate and all placement of polystyrene blocks on the left side in construction. Another example of the bridge, I showed you the speaker part, the Zutphen bridge. We also have made a design, so this is not in construction, just the design for a bridge it has a length of 1400 meters with 100-meter spans. And we are using here UHPC railings and deck plates, double T deck plates made out of C90-105 between the two railings. This is an artist's impression of the bridge, which we made the design for in Dambai in Ghana. This is one of their main rivers, and the bridge has a width of 11.5 meters. Here's another impression of the bridge. This is the cross section of the bridge. So what we plan to do is produce elements in UHPC in the Netherlands and transport the elements to Ghana for quick construction. So that is actually the plan for this. Further at FDN, we design many projects and constructions in concrete. So one of the products we had developed about 15 years ago are floating breakwaters. So currently we also have a project for which we are designing floating breakwaters, and the wave height to be damped is around 4 meters. So we are also making a design for a floating breakwater in high performance concrete. You can see on the next slide what this looks like, because high performance concrete is really a material for a sea environment, and with thin elements you can produce. So you can see this is a triangle shaped port in about 80 meters water depth, and so we will prefabricate elements in a dock and then pull them to site, tug them to site, and connect them with each other. So this is also a project from 2022 in the design stage, where we will consider also different kinds of UHPC, and also of course we'll compare it with the traditional C60 concrete. This is a cross section of the high strength concrete. We used C90-105, but more optimized will be a C120 quality concrete, to see how the elements look like. This is just for information. After designing the element, we always make some wave damping calculations to see whether the element, how it will work as a port structure. Thank you very much. If there are any questions, I can answer them now. Thank you.
Good. Thank you very much. Thank you very much. Okay, are there some questions in the audience here, or I don't know, in the questions and answering? Some questions? No, for the moment, no questions, but I see you have your email address in the presentation. We will share all these presentations for everybody present here to so that you can, for each topic, reach the people you want to reach, so that you will receive a link afterwards. What we also did is a recording of the whole seminar, so that will also be shared afterwards.